This is a tutorial for the Sieve Analysis Lab of the Geotechnical Engineering course Sieve 3208. The purpose of this lab is to determine the grain size distribution in a sample of soil. This is important to know, as coarse-grained soils like sand and gravel have different properties than fine-grained soils like silt or clay. In this lab, we will be filtering the soil sample through a series of progressively smaller sieves. Sieves are simply metal meshes of a particular size framed by a round rim. These are the sieves that we will be using. The sieve at the top has the largest hole size, while the sieve at the bottom has the smallest. There are many different sieve sizes available. You will need to make sure that your stack of sieves includes the following: the number 200 sieve at the bottom, that acts as a separator between silt and sand. Everything small enough to pass through this sieve is either silt or clay, and will be captured by the pan. The number 4 sieve is also important as it acts as a boundary between gravel and sand. In this stack, in order from bottom to top, we have sieve number 200, number 100, number 60, number 10, number 4, quarter inch, half inch, and 3/4 inch. We are using 8 sieves as that is the maximum number of sieves that a shaker can hold at one time. Make sure that the sieves you are using are in order from largest at the top to smallest at the bottom. You will also need a few containers such as these bowls and a scale. Finally, you will need a shaker such as this one. For this test, you will need a representative sample with a weight of approximately 1 kilogram. To obtain your sample, first place your container on the scale, zero the scale to negate the mass of the container, then measure out about 1 kilogram of soil. The sample does not need to be exactly 1 kilogram. Pour the soil sample into the top of the stack of sieves and cover the stack with a lid to prevent dust from escaping during the test. Take the stack of sieves and place it on the shaker. Place the top cap on the shaker and secure it by hand with the 2 screws. This will fix the sieve stack in place while it is shaking. Then set the shaker for 10 minutes of shaking. It will start automatically if it's plugged in. After the shaker has stopped, loosen the screws and remove the stack. Next, you will need to take the soil in each sieve and weigh it on the scale. To do this, we will use this container. Place your container on the scale and zero the scale. Pour the contents of the first sieve into the bowl, record the mass of the material according to the size of the sieve, and then pour the contents of the bowl into another container for storage. With the finer grain sizes, use the brush on the back of the sieve like this to remove as much of the material as possible. Make sure not to spill any of the sample when you do this. Finally, record the mass of the material in the pan. Using a table like this one, calculate the percentage of soil passing each sieve. First, add the total mass of material passing all sieves and record it. Next, calculate the cumulative mass passing each sieve. Starting from the top and working downward, the cumulative mass passed at each sieve is the mass passed by the next largest sieve minus the mass retained by that sieve. For example, the total mass of the sample was 1021.5 grams. The mass retained by the largest 3/4 inch sieve was 191.0 grams, which means that the mass passing this sieve is 830.5 grams. For the half-inch sieve, 131.7 grams was retained, which means that the mass passing this sieve was 698.8 grams. When you've done this, make sure your cumulative mass passed at the pan is 0 grams. If it's not, you have made a mistake in your calculations. Convert cumulative mass passed to a percentage of the total mass of the sample. To do this, simply divide the amount by the total mass of the sample and multiply by 100 for a percentage. Do this for each sieve size. Plot the percent passing each sieve versus the sieve size. This graph will use a semi-log scale. The y-axis will be a linear scale of the total cumulative percent passed from 0% to 100%. The x-axis is sieve size in millimeters. It is on a logarithmic scale from the smallest sieve size corresponding to the number 200 sieve, or 0.075 millimeters, to the largest sieve size, which was 3/4 inch, or 19 millimeters. Each sieve will correspond to one data point on this graph. Plot all the data points and connect them together like this. We now have a grain size distribution curve for our soil sample. This concludes the sieve analysis lab.